So in the previous video, I introduced the average rate of change of a function, and hopefully made the point that really all we're doing is calculating the slope of a line, something called the secant line, a line that connects two given points on a graph. In that video, I argued that the average rates of change can be calculated purely geometrically or purely algebraically, but in the example that I showed, I kind of did it both ways. So what I want to do in this video is keep things really short and just work through a couple of purely geometric examples to show you what I'm talking about. So pictured are two functions. Maybe we'll call the one in blue f and the one in red g. Suppose you were asked to find the average rate of change of this function pictured in blue, f, from x equals -2 to x equals +1. All this question is asking you to do is to create the secant line from x equals -2 to x equals +1. So let's see, x equals -2 right here, where the height of the function is -1, and x equals +1 right here, where the height of the function is 8. The secant line is just this straight line pictured in black that connects those 2 points on the graph. If I want to figure out the average rate of change of this function f from -2 to +1 as the x coordinates, all I got to do is figure out the slope of this secant line. To figure out the slope of the secant line, you could just kind of look at it and count. Looks like I go up 1, 2, 3 units each time I go 1 unit to the right. So it kind of appears that the slope here is 3. If I wanted to write things out a little bit more formally, maybe I'd say that the average rate of change, which as we saw in the previous video, is just the difference in the two y coordinates divided by the difference in the two x coordinates. I can get directly from these two given points. Note that in the problem I were given these two x values. Maybe I'll call the first one given to me x1, so x1 would be -2, and the second one, x2, would be +1. Well then to figure out this quotient, which has 4 different values in it, I already have 2 of them, I just need the additional 2, f of x1 and f of x2. F of x1 is just the same as f of -2 because x1 is -2. F of -2 is just asking me the question, what comes out of this machine when I put -2 into the machine? In other words, what is the y coordinate that corresponds with an x coordinate of -2? Based on this point right here, the y coordinate appears to be -1. Therefore, f of x1 is just -1. Similarly, for f of x2, all I have to do is figure out what is f of 1. Why f of 1? Because x2 is the value 1. F of 1 is just asking me the question, what comes out of the machine when I put 1 into the machine? Here's where I put 1 into the machine. It looks like what comes out is the number 8. Therefore, f of x2 is equal to 8. I now have all 4 values, 1, 2, 3, and 4, that go into this quotient. So all that's left to do is plug numbers in, subtract, and divide. F of x2 was 8. From that, I want to subtract f of x1, which was -1. And then I want to divide that by the difference in x2, which I'm calling 1 down here, and x1, which is -2. 8 minus -1 is the same as 8 plus 1, which is 9. And 1 minus -2 is the same as 1 plus 2, which is 3. So the average rate of change is 9/3. In other words, 3, the same slope that we saw visually when we just counted up and over units. In case that didn't make sense, let me do it one more time. Suppose you were asked to find the average rate of change of this function pictured in red, which I'm calling g, from x equals 2 to x equals 4. Again, I'm given 2 x values. Maybe I'll call the first one x1 and the second one x2. My average rate of change formula tells me that the average rate of change is just the difference in the two outputs, which maybe since my function's name is g, I'll write as g of x2 minus g of x1 this time, divided by the difference in my two inputs, x2 minus x1. 4 values that I need to plug into this formula, 2 of them are given to me in the problem. To figure out g of x1, because x1 is the number 2, I just have to figure out what is g of 2. G of 2 is just asking me the question, what comes out of this machine g when I put 2 into it? What is the output corresponding with an input of 2? The input is the x coordinate. Here's where the x coordinate equals 2. This point has a y coordinate of 0. Therefore, the output for this function g, when the input is 2, is 0. So g of x1 equals 0 because of this point. Similarly, to figure out g of x2, I just have to recognize that x2 is the number 4. So I got to figure out g of 4. G of 4 is asking what comes out of the machine when you put 4 into the machine. Based on this point right here at 4, 2, I see that the output corresponding with an input of 4 is the number 2. I have the 4 numbers that I need, 1, 2, 3, 4. I plug those into this formula, and I'll be done with this example and done with this video. G of x2 is the number 2. From that, I want to subtract g of x1, which is the number 0. And then I'll divide that by x2, which is the number 4, minus x1, which is the number 2. 2 minus 0 is 2, 4 minus 2 is 2, 2 divided by 2 is 1. So the average rate of change of this function pictured in red from x equals 2 to x equals 4 is just 1. One way you can visualize that answer is by drawing the secant line between those 2 points. If I asked you what was the slope of this line pictured in black, you might be like, well, it looks like it goes up 1 each time it goes over 1. Looks like the slope of this line is 1. Yeah, the slope is just the average rate of change. Average rate of change is 1. Slope is 1. Answer to this question is 1. End of this video.